but look for it on your, either in your notes or if you made a note card or something, look for it. What is the identity that links tangent squared and secant squared? It's one of them, yeah, it's one of the Pythagoreans, and it says 1 plus tangent squared is secant squared, right? So, if we rearrange that so that it says tangent squared minus secant squared, because that's the problem, that's the problem. So if I bring that secant over here and move that, what is this gonna equal? Tangent squared minus secant squared is gonna equal what? -1. So number 1 simplifies to -1. Just by rearranging your main one of your identities here. All right, what about number 2? Tangent over sine plus cosine. Any idea how we might start that one, Alex?
Isn't it tangent times sine?
Oh, it is tangent times sine. Thank you. Yeah, that makes a little bit of a difference. Thank you. Tangent times sine. All right. Any idea how we might start the right problem now? What's tangent? Sine over cosine. So let's think of it as sine over cosine times sine plus cosine. What does this equal right here? Sine squared over cosine, and it's still plus cosine. Well, what do we do when we want to add a couple things like this? What do we need to do? Get a common denominator, isn't that a fraction? So I'll get a common denominator, that would be this one, cosine squared over cosine. So what happens when I add them? I get sine squared plus cosine squared over cosine. If I get a common denominator for this one right here. What's that numerator? 1. And what's 1 over cosine? This you need to have memorized right now. What's 1 over cosine? Secant. Yeah. 1 over cosine. So that one, number, are these in order? Number 2 goes with B. All right, what about number 3? Tangent squared over 1 plus tangent squared. Anything there ring a bell? I actually have it written on the board. What's 1 plus tangent squared? Secant squared. So I have tangent squared over secant squared. All right. Any thoughts on where we might go from there? Tangent squared is sine squared over cosine squared. And what is secant squared? 1 over cosine squared. And what's going to happen when you do that division? Yep, the cosine squareds are going to be gone, and you're going to be left with just sine squared. Very good. All right, what do you think we should do with the next one? We are just simplifying these as best we can. So what do you think you should do with tan plus cotan? You absolutely could, Fred. let's just do it. I don't think that's gonna be the easiest way, but let's just do it, because it makes sense, so let's just do it. All right, and then what would you do? Common denominator, so that would be cotangent. So 1 plus cotangent squared over cotangent. Okay, then what?
1 plus cotangent squared.
Exactly. Fred says, I haven't memorized this yet because I've been in school forever, but that's important. I know I've seen that somewhere. So he's looking at his note. 1 plus cotangent squared is cosecant squared. Now what? What's cosecant squared? 1 over sine squared. And what's cotangent? Well, it is 1 over tangent, but I think that would really take, this is already a long and winding path, that would take us down more lines. What is cotangent? Cosine over sine. Cosine and sine are the building blocks. So if we would have changed these into sines and cosines in the beginning and gotten that common denominator, it would have saved us a little bit of work, but at some point, you need to get changed into sines and cosines. So this is 1 over sine squared times sine over cosine. What does that reduce to? Well, yeah, but no, just simplify that fraction. What do you get when you simplify that?
1 over sine.
You get 1 over sine cosine? Don't you? Is that the same as 1 over sine times 1 over cosine? Is that the same? And what's 1 over sine? Cosecant. And 1 over cosine is secant. So this is a perfect example, just like when you used to be in geometry class and you had to do those proofs. Sometimes you would just get rolling and it would take you 15 steps to do something that someone else did in 3, and that's okay. I personally would have rewritten the problem in sines and cosines from the beginning. And then gotten my common denominator, which would be sine cosine. But if I multiply this one by sine, so that it has the common denominator, and this one by cosine, so it has the common denominator, look at my numerator. And so that brings me right to here. Okay?
So we should always get it to sine.
I'm not saying always, I'm saying, yeah, it's a good idea to at least consider that. He said, look, these are reciprocal functions, I can easily change one into the other. That makes perfectly good sense too. But notice, eventually, what did we have to do? Change it into sines and cosines. So, you never know. Just keep an open mind. All right, what about number 5? People, help me out. What can you think of? Anything you can think of at all.
1 over cosine.
Change them into sines and cosines. So 1 over cosine minus sine over cosine times sine. denominator? So what have I got? The common denominator is cosine. 1 minus sine squared is my numerator. And so we are on problem 5. Do anyone notice anything? Avery?
1 minus sine squared is cosine.
Exactly. 1 minus sine squared is cosine squared. So this one simplifies just down to cosine. So one more time, remember, sine squared plus cosine squared is 1. You can rearrange that in many different ways. One way you can rearrange it is to move the sine squared to the other side. So this is what it says. Okay, you're not gonna memorize every version of every identity, but you have to recognize that they can be rearranged. So yeah, you're gonna memorize this, but it can show up in different arrangements. Beautiful. All right, what about number 6?
Numerator into cotangent squared.
Turn the numerator into something, he says. Now, if you don't have it memorized, that's okay. But you should at least remember that with the Pythagorean identities, they all three have ones and squared things. So when I look at cosecant squared minus 1, I'm immediately thinking that's something. What is that? I don't know. But I know my identity is 1 plus cotangent squared equals cosecant squared. That's what I'm gonna memorize. That's what I have up here. So if that's appearing in a little bit different form, what would that equal? If I made that cosecant squared minus 1, what would that equal? Cotangent squared. So I have cotangent squared over cosecant squared. Okay, now what? This is cosine squared over sine squared over, what's that? 1 over sine squared. And what happens to that? It's just cosine squared. Now, we haven't done one of these yet. Well, I mean, we haven't done one like this yet, but let's look at the original problem, just to give you another tool in your toolkit. It's a little algebra. Look at the original problem. That right there can be kind of uncommon denominator and written like this. Would you agree it could be, you could do that? That's an option. And this, of course, is 1. What's this? 1 over cosecant is what? Sine. They're reciprocals. So 1 over sine is cosecant, and 1 over cosecant is sine. What is 1 minus sine squared? Cosine squared? So that's another way you could have done the problem if that occurred to you. That's another option. All right, what about number 7? What do you want to do with number 7? Okay, so it would be 1 over sine over sine minus cosine over sine over sine over cosine. If we just decided we're gonna change it into sines and cosines, that would be an option. Alright, now what do you do with it now? Well, let's simplify each fraction first, then we'll get a common denominator. What's this? Oh my gosh, you guys. Now, if you think about this for a second, this is 1 over sine divided by sine, correct? That is 1 over sine times 1 over sine. These do not cancel. You can't cancel a denominator with a numerator. This is not 1. What is this? 1 over sine squared. So I have 1 over sine squared. Minus, okay, what's that? What's that going to equal? Cosine squared over sine squared. Now at this point, I would get a common denominator, but luckily I already have one. So now I've got 1 minus cosine squared over sine squared. Now that, friends, is 1. Because what's 1 minus cosine squared? Sine squared. So now we've got sine squared over sine squared. Alright, one more. And it looks good. What do you think you're going to do with problem 8? Yeah, FOIL it out, distribute it out. So let's see, I'm going to try to do that without writing it all out. That's going to be sine squared minus 2 sine cosine plus cosine squared. Is everybody okay with that FOILing? That's the first one. You okay with that? So what's the second one? This is plus sine squared plus 2 sine cosine. Okay, so I FOILed out each parentheses, and this is what I've got left. What do you notice about it? These cancel, right? What's this? 1. That's a 1, right? What's this? Another 1. So what does this one equal? 2. The answer is just 2. Because sine squared and cosine squared always add up to 1. Okay? Alright, let's take a look at the next page. And we'll do some multiple choice, and then we'll do some more identities over here if we have time. Okay. So, this picture is a tangent. So this picture is a tangent dx. And you are supposed to decide, well, let's decide first, if that picture is a tangent curve, which it is, supposed to be tangent. Is A positive number or a negative number? Positive. Well, how do I know it's positive? I don't know what it is, but how do I know it's positive? because the curve is going the way it's supposed to go. This is what a tangent is supposed to look like. So I know that it hasn't been turned upside down. So A is positive. So already we know the answer is either A or B. So now we gotta figure out, is B greater than 1? This number right here. Is that number greater than 1 or less than 1? Now, what does that number impact? In any graph, not just this one, in any graph in the whole wide world, what does that number impact?
Period.
The period. That is this dimension, right? So, I know in a regular tangent, the first vertical asymptote after the point is 0, the first positive vertical asymptote is supposed to be at pi over 2, right? Where is this one? This one is at pi. So obviously I have changed something, right? All right, what have I done? I multiplied by 2, right? And if I've multiplied by 2, what does this number have to be? That has to be a 1/2. Because remember, this number in this position is a divider. And if my asymptote got doubled, if the distance got doubled, then that number has to be a 1/2. Does that make sense to everybody? So that means A is positive and B is less than 1. All right, which of the following is the vertical asymptote? So another tangent problem. Remember that for a regular tangent, we have asymptotes at pi over 2 and 3 pi over 2. Those are regular asymptotes. Okay? Now what have I done here? I have divided by 4. Well, actually, that number, I multiplied by 4. So I've really multiplied by 4. So instead of this being here, where's it gonna be? At 2 pi? And where's this one gonna be? 6 pi? And so on and so on and so on. So which of these options describes that? C. C. Right, another tangent problem. Which of the following is the vertical asymptotes? The pi theta. So now, again, I'm gonna use my same picture here, but this time we divided by pi. So if I divide my asymptotes by pi, where are they gonna be? This one would be at 1/2, and this one would be at 3/2. Which answer matches up with that? K is an integer, so I think C is your answer, isn't it? In the XY plane, an angle theta is measured in standard position. So here's theta in standard position. The slope of the terminal ray, the slope is √3. So for example, this could be √3 over 1. So over 1 up √3. Which of the following could be the measure of angle theta? Now, I drew it in quadrant 1. I don't know what quadrant it's in, quite honestly, but just to get a visual, I put it there. If I put that scenario in the unit circle, this is not a unit circle, obviously, it's not. But if I put it in the unit circle, this would be the point 1/2 root 3 over 2. Does that make sense to everybody? What angle is that has that ordered pair? Pi over 3? Is pi over 3 an option for me? No. But 2 pi over 3 and 4 pi over 3 are options. Now think about that for a second. Would the slope, this is 2 pi over 3. Would that slope be positive root 3? No, that would be negative, wouldn't it? How about 4 pi over 3? Would that slope be positive? Yes, so that's the one. 4 pi over 3. Five is just like it. Can you figure out 5? This time the slope is 0. Well, that narrows it down right away. If the slope is 0, don't you have to be horizontal? So where are you? Pi would be the only option there. An angle in standard position has a measure of pi over 6. So on our unit circle, here we are at pi over 6. That is 3 over 2, comma 1/2. Slope is y over x. So which one of those is right? B? Easy, B. All right, try 7. We just spent a lot of time practicing our identities, so try 7. Your goal in number 7 is to take the left side and work your magic and make it into the right side. All right, so think about what are you going to do on the left side of that problem. Don't say it out loud, just go ahead and do it. What are you going to do on the left side of the problem? Everybody should have step 1 done. What did you do on the left side? FOIL it. So you had sine squared, 2 sine cosines when you did outside and inside, and then cosine squared. Okay, don't stare at me blankly. Are we zeroing in on this? We got this? Now, as you were writing that down, you're just beginning your journey, but as you were writing that down, this should stick out at you. If for no other reason than you're visualizing Mr. and Mrs. Passwater walking down the street, right? Sine squared plus cosine squared is 1, okay? So now I have 1 plus 2 sine cosine. If I were walking down the hall and found this, I would simplify it and I would stop here because that's simplified. But in this particular problem, I have a goal. I am supposed to be ending up with this. Okay, so now I have to recognize I've seen this before. What is 2 sine cosine? It's the sine double angle, right? It's the double angle sine. So this right here is the sine of 2x. And so now I'm ending where whoever wrote the problem told me I had to end. That wasn't too bad, was it? Not bad. All right, cosine, 5 pi over 12. We did one of these yesterday, or 2 maybe. Anybody remember how we start this? Pi over 12 is not one of our specials. And I think in my unit circle, pi over 12 isn't. What is? Pi over 3, pi over 4, 6. Those are mine, okay? So somehow, I've gotta rewrite that 5 pi over 12 as either the sum or the difference of some pi over 3s and probably pi over 4s, because that would make 12. So something over 3 and something over 4. I'm gonna get a common denominator and end up with 5 pi over 12. All right, so lots of options, many options. You can add or subtract. So, anybody have a thought?
Pi over 4, pi over 6.
Pi over 4 and what?
Pi over 6.
Oh, pi over 6. Well, let's add them and see if that gives us pi over 12. All right, you're gonna get 12 as your common denominator. It works, doesn't it? So one option would be pi over 6 plus pi over 4. Now there are others, so don't start freaking out. You find something that adds or subtracts to 5 pi over 12. Our answer will be the same. All this stuff will look different, but the answer will be the same. All right, so what do? Once I figured out that those two add up to 5 pi over 12, then what do I need to do? Look at my formula, my identity, for the cosine of two things added together. So what does that formula say? Cosine of the first, call it alpha. Cosine of the second, call it beta. Minus sine of the first, sine of the second. Okay, you find that formula? Cosine, cosine, minus sine, sine. And then we're going to start plugging in numbers. We know that the cosine and sine of pi over 4 is root 2 over 2. Don't we know that? Hopefully. Right now, pi over 6. Pi over 6. What's the cosine of pi over 6? Root 3 over 2. And the sine is 1/2. So when I multiply, this one is root 6 over 4. Root times root's root. Root 6 over 4. This one's root 2 over 4. And then we said yesterday we can write these as one fraction, but you can't ever combine. You can't subtract root 6 and root 2. They stay as two separate things. Do you remember doing that yesterday? Didn't we do that yesterday? Or the day before, whenever it was? We did that. All right. Last problem today. You and your partner work on B. It is exactly the same type of thing. You guys work on problem B. Sine 11 pi over 12. You can't do pi over 12s without rewriting them. So you gotta figure out how you're gonna rewrite 11 pi over 12. sometimes if I'm struggling, I take my unit circle and I give my special angles the common denominator that I need. So instead of pi over 6, I wrote 2/12 and 3/12 and 4/12. And that kind of helps me sometimes. You don't have to do that at all, but it helps me. So I chose 3 pi over 4 and pi over 6. Did anybody choose something different? What'd you guys do, Alex?
I did pi over 4 and 2 pi over 3.
Pi over 4 and 2 pi over 3. Okay, anybody have a different idea? Sophia?
I did 5 pi over 3 minus 3 pi over 4.
She did subtraction. 5 pi over 3 minus what?
3 pi over 4.
3 pi over 4. She did a subtraction. Awesome. Anybody have a different one? Now, I'm gonna go ahead and do my problem. Maybe you're already done with yours. If not, keep going, get it done, because I want you to see the answer is gonna be the same, no matter what. So I'm using my sign. I'm using the sign sum. Sophia's using the sign difference. Built-in trap here is sometimes, like, well, for Sophia, both of her angles are not in quadrant 1. And so when she starts doing the sines and cosines of them, something will be negative. So you have to remember that. If your angle is not in quadrant 1, like this guy right here for me, sine is still positive, but the cosine is negative. So you have to keep track of that. In the middle of everything. Okay, Sophia, are you done?
Yeah.
Did you get this?
Yeah.
Yep. Alex, did you get this? Uh-oh.
I did.
You did?
I got negative 6. Or I got negative root 6 instead of, or I got negative root 6 plus root 2.
You did it wrong. I did the same thing. I got that.
So yours look like sine pi over 4, cosine 2 pi over 3, plus cosine pi over 4, sine 2 pi over 3. That's what yours look like? Okay, the cosine of 2 pi over 3 is negative a half.
Oh, I just looked, yeah.
Okay, 312 is due on Monday. Our quiz will be Monday. Tomorrow we will continue. We'll probably finish up this review sheet, or at least most of it. If you are so inclined and want to look through the review sheet and notice, oh man, I don't remember ever seeing anything like, I don't know, number 15, then we'll do that, all right? But otherwise, I'm just going to pick up where we left off and get as much done as we can.
Is 311 due today or tomorrow?
Could be wrong on that.
No, 311 was yesterday. 310.
Okay, everybody.
Yeah, I'm all for it. I'm at
312 is Monday. Monday.
Wait, actually, I might still have my stuff.